did Earth just get a message from another galaxy? Stick around, hit subscribe, and let's find out. So, here's the thing. A few weeks ago, Earth's magnetic shield, that invisible bubble protecting us from solar storms and cosmic radiation, jolted in a way scientists had never seen before. It wasn't caused by the Sunday. It wasn't caused by a nearby star. It lined up exactly with a faint energy burst that came from the Andromeda Galaxy. Now, Andromeda is not exactly next door. It's 2.5 million light years away. That means if someone or something there sent a signal, it would have left around the time our early human ancestors were just learning to use stone tools. And yet, here we are. The timing of this signal and the sudden spike in Earth's magnetic field matched too perfectly to ignore. Coincidence? Maybe. But scientists are whispering that it might not be random at all. In this video, I'm going to take you on a journey. We'll break down what really happened with Earth's magnetosphere, why this strange event has shaken the scientific community, and what it could mean for our planet and our place in the universe. And along the way, we'll open doors to theories that sound almost like science fiction, but are grounded in data too weird to ignore. So let's start at the very beginning. What exactly is Earth's magnetosphere? Imagine the Earth as a cosmic fortress, and the magnetosphere is its shield. It's invisible, but is constantly deflecting solar wind, high-energy particles, and cosmic radiation that could fry satellites and power grids if they ever got through. Without it, you and I couldn't even survive on the surface. Normally, disturbances in this shield come from the Sunday solar flares, coronal mass ejections. You know, giant eruptions on the sun's surface that send waves of plasma flying through space. When those hit Earth, our magnetic field shakes. Auroras light up the skies, and satellites sometimes get knocked offline. It's been happening for billions of years. Nothing new there. But this time, it wasn't the Sunday. The sun was quiet. The solar weather forecast showed no storms, no flares, nothing that could explain the sudden jolt scientists picked up. Instead, at the exact same moment, instruments across the world, NOAA ground stations in the US, ESA's swarm satellites orbiting above, and even new experimental quantum-grade sensors all picked up the same thing, a burst of energy, like a fingerprint coming from deep space. And when they traced it back, the origin was Andromeda. Think about that for a second. That's another galaxy, not another star system, not even the edge of our Milky Way, an entirely separate galaxy. And yet somehow, something from there shook Earth's protective shield. Now, here's where it gets interesting. The signal itself wasn't powerful. In fact, it was surprisingly weak. But it wasn't about strength, it was about precision. Scientists noticed that the signal matched one of the natural resonance frequencies of Earth's magnetosphere, like striking a tuning fork at exactly the right pitch. Even a small vibration, if it's at the right frequency, can make the whole structure hum. This led to the first theory, the resonance trigger hypothesis. The idea is simple but powerful that even a faint cosmic signal, if it lines up with Earth's natural frequencies, could create an amplified effect, like a whisper that makes the ground tremble. Others propose something even stranger. The intergalactic magnetic bridge. Imagine space not as empty, but as threaded with invisible filaments of plasma, stretching between galaxies like spider webs. These filaments can carry magnetic fields across incredible distances, holding their structure for millions of light years. If that's true, then maybe the burst from Andromeda didn't just radiate randomly across the void. Maybe it traveled along one of these filaments, a kind of cosmic highway, and arrived at Earth intact, sharp enough to resonate with our magnetosphere. And then there's the wildest possibility of all that the signal was intentional. Let me explain. The timing wasn't just close, it was exact. Down to fractions of a second, the burst lined up with Earth's magnetic spike. That kind of precision is hard to brush off as chance. And while scientists are cautious because words like intentional carry heavy implications, the data doesn't lie. It looked almost targeted. Which begs the question, if this was a message, who or what sent it? And why Earth? Before we dive into that rabbit hole, let's step back in time for a moment. This isn't the first time Earth's magnetic field has danced to the tune of something far away. Back in 2004, a magnetar, a kind of neutron star with insanely powerful magnetic fields, unleashed a burst in our own galaxy. For a brief moment, Earth's magnetic field actually vibrated in sync with it. Think about how crazy that is. A star tens of thousands of light years away made our planet's shield quiver like a drum. So we know it's possible. Distant cosmic events can absolutely rattle Earth's defenses. But Andromeda isn't tens of thousands of light years away. It's millions. That distance should smear, weaken, and scramble any signal beyond recognition. And yet, this one arrived with fingerprints so clean they almost looked too designed. Now here's where the story starts to take a turn. If Earth really is part of a vast electromagnetic web, a network of invisible threads linking galaxies together, then maybe we've underestimated just how connected we are to the cosmos. Maybe Earth isn't just sitting alone in a void, but is wired into a system that stretches across unimaginable distances. But here's the problem. Our entire modern world depends on the stability of Earth's magnetic field. GPS navigation, power grids, airplanes, spacecraft, even stock markets all rely on technologies that can be disrupted by magnetic instability. If bursts like this keep happening, even if they're rare, they could introduce risks we're completely unprepared for. So, was this a one-time cosmic accident? Or are we just waking up to a much bigger pattern? We'll explore that in the next section. But first, let's pause and think about what this means. If this was a random cosmic event, it's fascinating but manageable. But if it wasn't random, if this was a signal traveling 2.5 million years to land on Earth's shield with perfect timing, then maybe we just heard a knock at the cosmic door. And the real question is, are we ready to answer? Imagine this. You're standing in your backyard at night, staring up at the stars. Everything looks calm, quiet, eternal. But at that very moment, deep above your head, Earth's magnetic shield is quivering. Invisible waves are rippling across it, and none of us can see it. It's like standing in the middle of an ocean and not knowing a giant wave just passed beneath your feet. That's exactly what happened during the Andromeda event. The skies were calm, the sun was quiet. But Earth's defenses shifted ever so slightly, almost like a heartbeat skipping a beat. The only reason we even know this happened is because of the instruments. NOAA's ground stations in Colorado and Alaska picked up the first hints. A sudden spike, sharp but brief, recorded on magnetometers designed to track solar storms. At first, the data looked like noise, maybe an equipment glitch. But then the European Space Agency's swarm satellites orbiting hundreds of kilometers above Earth reported the same thing at the same time. Here's something to think about. Earth's magnetic field isn't just an invisible bubble in space. It's the shield that makes life possible. Without it, the constant wind of radiation from the sun would strip away our atmosphere in a matter of centuries, maybe less. The oceans would slowly evaporate, the ground would bake, and life as we know it would vanish. That's why scientists take these spikes so seriously. Even a tiny wobble in the magnetosphere can ripple through the systems we depend on every day. During the Andromeda event, pilots flying polar routes reported strange compass shifts. Navigation satellites in medium Earth orbit experienced slight fluctuations. Power grid operators in Canada saw anomalies in their monitoring stations. These weren't catastrophic failures, nothing blacked out, no planes fell from the sky, but they were enough to prove a point. Whatever hit Earth wasn't just theoretical, it was tangible. It brushed against our daily lives. And that's what scares people most. Because when we think of danger from space, we picture giant asteroids, or massive solar flares, or gamma-ray bursts. Big events that make the news. But this was subtle. It was quiet. A whisper, not a roar. And yet, it got through. Now imagine if it happens again, but stronger. Here's the challenge scientists are wrestling with. If this really was a one-time accident, we can move on. But if it's repeatable, if Earth can be played like an instrument, then suddenly our shield isn't as invincible as we thought. This is where the resonance trigger hypothesis comes into play. Think of Earth's magnetic field like a swing in a playground. If you shove it randomly, it just wobbles and stops. But if you push at the right rhythm, even small pushes can make it swing higher and higher until it's soaring. That's resonance. The Andromeda burst may have been just one push. But what if more are coming? What if a series of signals, spaced just right, could amplify the oscillations of our magnetosphere? Could that destabilize it? Could it weaken it? Could it even break it? Nobody has the answer. And that's the problem. But here's where things get even more eerie. The timing of the signal, August 6th, 2025. That date doesn't mean much to most people, but to astrophysicists it was peculiar. Why? Because the sun was at a quiet phase. There were no solar storms, no coronal mass ejections, no space weather events to confuse the data. It was the perfect quiet sky, which makes the Andromeda spike stand out even more. It's almost like whoever or whatever sent it knew when to strike. Now, let me ask you something. What do humans do when we want to get someone's attention, across a distance, we wait until it's quiet. You don't knock on a door during a thunderstorm. You wait until the house is silent, so your knock is unmistakable. That's exactly what this looks like. And if that's true, then we have to face the possibility that the knock wasn't just for science. It was for us, humanity, the people in charge, NASA, ESA, NOAA, private labs. They're being careful with their words. Publicly, they call it a fascinating anomaly. But behind the scenes, they're scrambling. Teams are now combing through decades of magnetometer data to see if this has happened before. And the results? Whispers are already leaking. There may have been similar spikes in the past, faint ones, buried in noise, overlooked because the instruments weren't sensitive enough. What makes this different is that now we have the technology to notice. The quantum-grade sensors, the satellites, the ground networks, they've made the invisible visible. And that raises a haunting thought. What if the universe has been talking to us all along and we just weren't listening? Imagine living next to a neighbor who knocks on your wall every night, but you only just bought a hearing aid that lets you notice it. That's the position we're in now. We're hearing the knocks for the first time, but here's the twist. If someone is knocking, do we dare knock back? Because that's the crossroads humanity now faces. Do we treat this as a random quirk of physics? Or do we take the bold step of responding, of sending a signal back along the same cosmic bridge? Some scientists argue we should. Others say it's reckless. What if we're not ready for whoever's on the other side? What if the knock wasn't friendly? And then came the clincher. A network of experimental quantum sensors so sensitive they can pick up changes at the tiniest scale showed the exact same anomaly. Not only that, but their timestamps matched the Andromeda signal to fractions of a second. That's when scientists realized this wasn't noise. It was real, and it was coordinated. Now, let's pause here for a moment. Imagine 3 different orchestras on 3 different continents, all playing the exact same note at the exact same time without rehearsing. That's how unlikely this alignment was. But here's where things get even more fascinating. The frequency of the burst, the actual tone of the signal, wasn't random. It matched one of the natural resonant frequencies of Earth's magnetosphere. If Earth's magnetic shield were a musical instrument, this would have been like plucking its string at just the right spot to make it sing. This is what scientists call resonance. You've probably seen videos of a singer shattering a glass with just their voice. The note doesn't need to be loud. It just needs to be precise. The Andromeda signal, tiny as it was, hit Earth in that same exact way. Now, if that doesn't already raise eyebrows, let me add something else. The burst didn't just arrive and vanish. For a brief moment, Earth's magnetic field actually hummed. Think of it like a bell that rings after you tap it. The aftershocks lasted nearly a full minute. That might not sound long, but in geophysics, that's huge. So naturally, the question came up. Was this a fluke of nature or a deliberate act? And that's where the community split. One camp says this was a natural resonance effect, no big deal. Maybe Andromeda has a magnetar or a black hole emitting faint but steady pulses, and we just happened to get hit by one that matched our frequency. Lucky timing, nothing more. The other camp, smaller but louder, says the alignment is too sharp to dismiss, that the precision was unnatural, almost like something was tuning Earth on purpose. Now, let me be clear. No scientist is coming out and saying aliens. That's career suicide. But they are saying intentional. And in science, that word is a loaded gun. Here's why. For something to be intentional, it means the signal wasn't just noise from the universe. It means someone or something designed it to get our attention. It means that across 2.5 million light years, a beam of energy was aimed with surgical accuracy at Earth, timed so perfectly that it would resonate with our protective shield. Think of throwing a stone into a pond, but instead of hitting anywhere, you land it exactly on a leaf floating in the middle. That's the level of precision we're talking about. And if that's true, then Earth wasn't just randomly hit, it was targeted. Now let's dig a little deeper into how that could even be possible. One explanation is the magnetic bridge theory. Scientists believe that galaxies aren't isolated islands. They're connected by faint filaments of plasma cosmic highways that carry magnetic fields between them. If that's true, then maybe someone or something in Andromeda learned how to use those highways. Maybe they didn't just shout into the void, maybe they whispered into a wire that stretches all the way to us. Think of an old telegraph system where signals travel down long wires across continents. What if the universe already has a version of that, built into its very structure? Plasma filaments acting as wires, carrying signals from one galaxy to another. It sounds like science fiction. But the mathematics actually works. In fact, some plasma physicists have already modeled how magnetic fields in filaments can stay coherent over unimaginable distances. So here's the big question. If this really was a message, what did it say? That's the haunting part. Because so far, it doesn't look like data. There were no obvious patterns, no binary codes, no pulses that could be translated into language. It was just energy, pure resonance. Like someone knocking on the door, but not saying a word. And maybe, just maybe, that's the point. When you knock on someone's door, you don't yell your whole story through the wood. You just knock and wait for them to answer. That's exactly what this feels like. A knock, a first contact. But here's where the problem comes in. If this was intentional, why now? Why here? And most importantly, what comes next? Because one knock usually isn't the end. It's the beginning. And here's where the tension really grows. Because history has taught us something. First contact between civilizations almost never goes well for the weaker one. That's the shadow hanging over the Andromeda event. The question no one dares to say aloud, but everyone is thinking, if someone knocked on our shield, is it because they're curious or because they're checking if it's strong enough to withstand a second hit? Here's where things get really unsettling. This isn't the first time Earth's magnetic field has danced to the tune of something far away. Back in December 2004, a magnetar in our own Milky Way, basically a star so dense and unstable It's like a cosmic ticking time bomb released a burst of energy. That single flash, lasting just a fraction of a second, was powerful enough to make Earth's magnetic field ring like a bell. Imagine holding a tuning fork, tapping it once, and then hearing the vibration echo for minutes afterward. That's what happened to our entire planet. And the scary part? That magnetar was 50,000 light years away. So when scientists saw the Andromeda spike, they thought back to that event. If a burst from that far could rattle us, then something closer or more precise could do even more. But there's another difference. The magnetar blast was chaotic, messy, like an explosion. The Andromeda signal wasn't. It was sharp, brief, clean, almost surgical. Like the difference between thunder booming in the distance and a knock on your front door. And that's what keeps scientists awake at night. Because if it was natural, it should have looked messy. If it was a coincidence, it shouldn't have lined up so perfectly with Earth's natural resonant frequencies. The odds of that are almost impossible to calculate. Meanwhile, governments and agencies aren't just sitting on their hands. Behind closed doors, NASA and ESA are pooling data, calling it cross-verification. But off the record, researchers admit there's tension. Some want to go public right now, shouting it from the rooftops. Others are terrified of causing panic. And then there are the defense agencies, the Pentagon, the European Space Operations Center. These groups don't just think in terms of science, they think in terms of threat. If a signal can shake our magnetosphere, even slightly, what does that mean for military satellites, for missile defense, for secure communications? Think about it. Entire navigation systems depend on GPS satellites locked in delicate orbits. Banking transactions rely on precise timing from those same satellites. The stock market, airlines, shipping, even power grids, all of it could be disrupted by a magnetic push at just the wrong time. And so, while the public sees a headline here or there about mysterious cosmic signals, the real work is happening in classified labs. Scientists combing through petabytes of data, quantum computers modeling scenarios of repeat events, analysts drawing up emergency protocols just in case. And here's where it gets interesting. Whispers suggest that this wasn't the first spike in 2025, that there may have been earlier tremors, smaller ones ignored at the time. Some claim the new generation of quantum sensors only started picking them up in recent months, which means we may already be part of an ongoing conversation without realizing it. The question is, who's on the other end? And here's the unnerving part. When you look back at ancient history, you'll find that humans have always recorded strange lights in the sky, mysterious disruptions in compasses, odd auroras that appeared during times of quiet Sunday. Could it be that these weren't just myths? Could it be that our ancestors experienced similar knocks, but without the tools to measure them? If that's true, then this isn't just a one-off anomaly. It's a pattern, a repeating phenomenon stretching back centuries, maybe millennia. But now, for the first time, we can actually see it and measure it and track it. That's both a blessing and a curse, because the more we understand, the more unsettling the questions become. What if these signals aren't just background noise? What if they're kind of intergalactic code, pulsed through cosmic filaments, those magnetic bridges scientists are only beginning to understand? Filaments that stretch across galaxies, carrying plasma and fields like invisible highways? If so, then Earth isn't isolated at all. It's plugged into a vast electromagnetic web, a web that might connect us directly to civilizations we've never met across unimaginable distances. That changes everything. No longer are we just passengers orbiting a star, protected by a magnetic bubble. We might be part of a larger system, a network, a community, or a battlefield. And that realization forces us into a corner. Do we treat these events as harmless cosmic quirks? Or do we prepare for the possibility that they're deliberate? Because if they are deliberate, then August 6, 2025 wasn't just another day in science. It may have been the first time in human history that someone or something from another galaxy reached out and touched us. What comes next feels like something straight out of a science fiction novel, except it isn't. Because when scientists reviewed the Andromeda spike, they realized something chilling. It didn't just rattle Earth's magnetic shield. It resonated, like a wine glass humming when a singer hits the perfect note. The Earth has natural frequencies, deep, slow oscillations called Schumann resonances that pulse in the space between the ground and the ionosphere. Normally, these frequencies are gentle, stable, like the heartbeat of the planet. But on August 6th, they surged, momentarily amplified, as if the Earth itself was responding to the knock. And here's the terrifying implication. Resonance is how you break things apart. Soldiers use it to shatter bridges. Engineers fear it in skyscrapers. And if a carefully tuned signal could push Earth's magnetic field into resonance, even briefly, what else might be possible? Some researchers whisper about a magnetospheric Achilles heel, that if the frequency were just right, stronger, sharper, it could create cascading failures, satellites flying in orbit, power grids flickering out, maybe even shifts in the delicate balance that shields us from solar radiation. Of course, officially, no one wants to say this out loud. But unofficially, the question is spreading. Was this a test? If it was, someone out there now knows our planet's resonance point, and that knowledge is power. Governments know this. And that's why, in the weeks after the event, meetings weren't just happening at NASA or the European Space Agency. They were happening in military bunkers. In classified strategy rooms, quiet calls were made between Washington, Brussels, and Beijing. Calls that never made the evening news. Because this isn't just science anymore, it's national security. But the divide inside the scientific community is growing. On one side are those who see the spike as a cosmic hello, a handshake across the stars. They argue that not responding would be like ignoring a knock on your door in the middle of the night. Scary, yes, but also potentially life-changing. Imagine what humanity could learn if this really is a message. Imagine being part of a galactic community. On the other side are the cautious ones, the realists. They argue that responding could be catastrophic, that announcing ourselves could attract attention we're not ready for. As one researcher put it off the record, if you're in the woods and you hear a twig snap, you don't shout, "I'm over here." And this argument isn't just philosophical, it's practical. Because some nations are already experimenting with low-frequency transmitters that could, in theory, send signals beyond Earth. Experiments justified as deep space research, but in reality, they could be the first steps in answering back. Meanwhile, the public is left in the dark. The news cycle churns through other stories. The Andromeda spike fades from the headlines. But in back rooms, the debate intensifies. Do we open the door or keep it shut? And then there's the strangest layer of all. When analysts mapped the timing of the spike down to the millisecond, they noticed something bizarre. It aligned almost perfectly with a natural fluctuation in Earth's lightning activity, a global spike in thunderstorms recorded by satellites, happening at the exact same moment. Coincidence? Maybe. Or maybe the signal wasn't just received, maybe it interacted, maybe it piggybacked on Earth's own systems, amplifying itself through natural processes we barely understand. If that's true, then whoever sent it might already know more about Earth than we think. They might know how to use our own planet as part of the message. And that raises the ultimate question. Was this just a test of communication or a demonstration of control? By this point in the timeline, even the calmest scientists are uneasy. Because if the spike can resonate with Earth, what happens if there's a second one? Or a third? What happens if the knock becomes a rhythm, a pattern, a drumbeat we can't ignore? And what happens if the door finally swings open? What makes this story even stranger isn't what we officially know, but what we aren't supposed to know. Because while agencies like NASA, NOAA, and ESA quietly published technical papers about the spike, other documents began to circulate. Documents not meant for public eyes. One of the first came from a whistleblower at a European research centre. They claimed anonymously, of course, that during the Andromeda event, signals didn't just come in, something went out. According to their leak, low-frequency transmissions were detected, leaving Earth just seconds after the spike, bouncing from one military installation to another and then outward, toward the stars. Now, here's the question that keeps people awake at night. Was this automatic? Like an echo, Earth's magnetosphere responding naturally? Or was it deliberate? Was someone or some hidden program waiting for the knock, ready to knock back? When pressed, the agencies denied it. They said no such transmissions existed. They called the leak misinterpreted data. But the timing is suspicious. Because within days, amateur radio operators around the world started reporting something bizarre. Faint, low-frequency pulses. Too regular to be noise. Too structured to be chance. The kind of signal that doesn't belong to storms or static. It happened in Canada, then in Brazil, then in Japan. Hobbyists posting online described it like a hidden beat beneath the static, a rhythm faint but undeniable. And here's the kicker. Those pulses match the timing of the Andromeda spike almost perfectly. Coincidence? Maybe. Or maybe, just maybe, Earth had already responded. But if that's true, who gave the order? Who has the authority to speak for Earth, to speak for all of us? That's where the story splinters into shadowy speculation. Some point to secret space defense programs, the kind that rarely make headlines but swallow billions of dollars each year. Programs rumored to have satellites with unknown capabilities, sensors more advanced than anything disclosed to the public, and perhaps transmitters powerful enough to send a message across galaxies. Others whisper about rogue experiments. Independent groups who've long dreamed of contact, who might have seized the moment to act while governments hesitated. And then there's the strangest theory of all, that it wasn't us, that Earth itself, through resonance, through magnetospheric echo, sent its own reply, not words, not a code, just a reflection, like a mirror returning a beam of light. A cosmic, "We heard you." Whatever the truth, something changed after the spike. Satellite anomalies increased slightly, nothing catastrophic, but noticeable to those who track them. A few unexplained communication dropouts, GPS glitches that lasted longer than normal. Small things, easy to brush aside. But to those paying attention, they felt like ripples. Ripples from a stone thrown into a very, very deep pond. And here's where it gets unsettling. Because when astronomers turned their eyes back toward Andromeda, they didn't see silence. Weeks later, faint fluctuations appeared again. Not as strong, not as sharp, but present, as if waiting for a response, or acknowledging one had already been sent. The official reports, quiet. The public statements, minimal. But inside classified circles, the chatter grew louder. What if contact had already been made, and none of us were told? Here's something people don't often think about. When an event like this happens, it's not just machines that carry the weight. It's people, scientists, engineers, analysts sitting in dimly lit rooms, staring at data that doesn't make sense, trying to decide whether to stay quiet or speak up. Imagine being one of them. You're trained your whole life to believe in order, in models, in equations. The universe follows rules, but suddenly the rules are broken, and you're the first to see it. Do you tell the world, or do you keep it locked away, knowing panic could ripple faster than any signal? Some couldn't hold it in. Quiet conversations began, not in public meetings or press conferences, but in late-night emails, encrypted chats, private forums. A few scientists dropped vague hints, wrapped in technical jargon, as if hiding the truth in plain sight. And slowly, people started to notice. A physics professor in Norway mentioned a resonant spike tied to a distant transient during a university lecture. Students uploaded the clip online, and suddenly conspiracy forums lit up. An engineer at an aerospace contractor hinted on Twitter about data they won't publish yet. That tweet was deleted within hours, but screenshots live forever. Even within NASA, there were murmurs. Staffers who usually joked openly about anomalies grew strangely quiet, or worse, defensive. That silence, that refusal to talk, spoke louder than any explanation. Meanwhile, the public mood began to shift. Most people went about their lives as if nothing had happened. After all, official news channels barely touched it. A one-line blurb here, a short science update there, but the online corners where rumors grow, they were buzzing. People asked questions. If Earth's magnetosphere can resonate with something from another galaxy, what else can reach us? What else has already reached us without being noticed? Some worried about technology. Pilots posted about strange compass readings mid-flight. Amateur drone flyers claimed GPS errors were more common than before. Were they connected? Nobody could say for sure. Others went deeper. Religious leaders spoke of signs from beyond. Mystics framed it as a message, not science, but prophecy. To them, Andromeda wasn't just a galaxy. It was a voice, a warning. And the strangest part? The silence of governments made it worse. Because when officials refuse to comment, people fill the gap with imagination. And imagination, especially in the dark, can be far scarier than truth. There's a pattern in history worth remembering. Whenever something unknown brushes against a human understanding, society fractures. Some demand answers. Some demand silence. Some cling to belief. Others to denial. And that's exactly what's happening here. Behind closed doors, the question whispered among scientists wasn't just what happened, but what do we tell the public? Because once you admit that signals from another galaxy can touch Earth, even briefly, you can't close that door again. And if there was already a reply, whether natural or deliberate, that changes everything. It moves us from being watchers of the universe to being participants in it. And not everyone is ready for that. Here's the thing. Whenever something unknown brushes against human reality, governments never sit still. They move quietly, behind curtains, while the rest of us are distracted. And this event with Andromeda was no different. We know this much. Within 24 hours of the magnetic spike, defense agencies around the world had locked it. The US Space Command flagged it. ESA cross-checked data. Russia's Cosmos Division issued unusual encrypted transmissions to its satellites. And China? They immediately scheduled new launches, not weather balloons, not telecom satellites, but classified payloads under the veil of communications upgrades. But let's be honest, none of this was coincidence. Because the first question every leader asks in a crisis isn't what is it? It's what does it mean for us? For the US, the worry was defense. If a signal could target Earth's magnetic shield with that precision, what else could be aimed at us? Could power grids be fried? Could GPS be disrupted at will? For Europe, the fear was vulnerability. A continent already tied together by shared systems, air traffic control, rail, finance, realized just how fragile that interconnection was if the magnetic field itself could be rattled. For China, the perspective was opportunity. If there truly was a pattern, a signal, a communication, whoever understood it first could leap decades ahead in technology, power, and influence. And so, their scientists worked in silence, sharing nothing, while their leaders pushed for more control over sky, space, and information. And then there's Russia. Historically, their strategy has been suspicion. Every anomaly is treated as an attack until proven otherwise. Some leaked reports suggest Russian analysts framed the Andromeda spike not as cosmic accident, but as directed interference. If they truly believe that, imagine what kind of military planning is already underway. The truth is, secrecy breeds paranoia, and paranoia breeds preparation. Satellite networks quietly shifted priorities. Intelligence agencies rerouted budgets into deep space monitoring. Militaries began running drills not just for cyber attacks, but for electromagnetic failures, the kind that could cripple entire cities if the magnetosphere falters. But here's the part no one talks about: collaboration. For all the rivalry, the back-channel science networks lit up the same way Cold War enemies once shared data about asteroids. These nations traded just enough information to keep themselves safe, but not enough to lose the advantage. Meanwhile, ordinary citizens weren't supposed to know any of this. News stayed muted, reports stayed buried, but every now and then, something slipped. An unusual power outage in a European capital blamed on equipment failure. A military plane diverting mid-air because of navigation issues. A meeting between space agencies that was never announced but somehow leaked. Individually, they look like noise. Together, they paint a pattern. A picture of world powers suddenly preparing for a threat they can't define but also can't ignore. And that raises the most chilling question of all. What if the Andromeda signal wasn't a one-time event? What if it was just the first ripple, a test, a knock on the door before the real message comes through? If that's the case, then the scramble happening in boardrooms and war rooms around the world isn't about what just happened. It's about what's about to happen next. And maybe they already know more than they're saying. Science, at its heart, is a language, a way of taking chaos, wrapping it in equations, and whispering back to the universe, we understand. But when the Andromeda spike arrived, even the most seasoned astrophysicists found themselves staring at graphs that seemed to whisper something else entirely. You don't know as much as you think you do. Still, scientists did what they always do. They tried to explain it. And from the thousands of hours of data, from the endless late-night meetings and whiteboards scribbled until the markers ran dry, 3 ideas began to take shape. The first is called the resonance trigger hypothesis. Think of a guitar string. When the right frequency is played nearby, the string will vibrate, even if you never touch it. Earth's magnetosphere works in a similar way. It has natural frequencies, subtle rhythms, beats in the invisible music of our planet. The resonance trigger theory suggests that even the faint pulse from Andromeda, if tuned just right, could have caused our magnetic field to shudder like a plucked string. In other words, the event wasn't about brute force, it was about precision. The signal didn't need to be powerful, it only needed to be perfectly timed. The second theory is far stranger. The intergalactic magnetic bridge. Picture the universe as a web. Galaxies aren't floating alone in empty space. They're connected by filaments, vast strands of plasma threaded with magnetic fields. These filaments stretch across millions of light years, invisible highways of energy and matter. Now imagine if those filaments could carry not just random currents, but structured signals, like a cosmic telegraph wire, sending a pulse across the unimaginable gulf between Andromeda and Earth. If true, this would mean the universe isn't just scattered islands of stars, it's a connected network. A network where information can travel, intact, across distances we once thought impossible. And then there's the third theory, quantum-grade detection. This one doesn't focus on what the signal was, but on how we saw it. In the last decade, our instruments have changed. Quantum sensors, unimaginably sensitive devices that measure the tiniest shifts in magnetic fields, are now running in labs and satellites. They can pick up what older machines would have dismissed as background noise, which leads to a haunting possibility. Maybe these signals have been happening for centuries, even millennia. Maybe Earth has always been a node in this cosmic network, and only now, with our new tools, are we finally hearing the whispers. 3 theories, 3 attempts to cage the unknown. Resonance, bridges, sensors. But here's the truth no one wants to admit. None of these theories fully explain what happened. They fit parts of the puzzle, but not all of it. The precision of the timing, the scale of the energy, the way the magnetic spike aligned across continents. It's as if we're looking at the shadows of something bigger without seeing the thing itself. And maybe that's the real point. Maybe this wasn't an accident. Maybe the universe doesn't reveal itself all at once. It gives us hints, clues, whispers, enough to unsettle us, but never enough to let us sleep soundly. Because if this event really was a message, if Andromeda just knocked on Earth's door, then these 3 theories aren't answers at all. They're only the beginning. Long before we had satellites and quantum sensors, the sky itself kept a record. People wrote down strange lights, instruments acted up, and trees stored secrets in their rings. Those old signs help us put the Andromeda spike into a timeline that stretches back centuries, even millennia. The most famous early case is the Carrington event in the year 1859. It began with a bright flash on the sun, followed by a storm of particles that reached Earth. Telegraph systems, the high-tech backbone of the time, started throwing sparks. Operators received shock. Some telegraph lines ran without batteries because the current induced in the wires was so strong that the machines continued to send messages on their own. Auroras lit up the night sky as far south as the Caribbean. People who had never seen the northern lights watched crimson curtains painting the heavens over Havana and Rome. The world back then ran on wires and gears. That storm showed how fragile those systems could be when space ripped open its power across the planet. Fast forward to the late 20th century. On a chilly March day in the year 1989, a solar storm hit the Earth with a force that blacked out an entire province of Canada. Quebec's power grid failed, and more than 6 million people were plunged into darkness for 9 hours. It was not as dramatic as Hollywood meteors, but it was real and immediate. Transformers overheated, relays tripped, and the delicate choreography of power supply collapsed. That event is the kind engineers point to when they talk about modern fragility. Our world runs on timing and electricity, and the magnetosphere keeps the orchestra in time. If the conductor stumbles, the instruments fall out of tune. Then there are bursts that come from strange dead stars. In the year 2004, a magnetar in our galaxy erupted. A magnetar is like a cosmic pressure cooker, a dense neutron star spinning with deep magnetic fields. When that one flashed, it sent a gamma-ray burst so intense that it disturbed the ionosphere on Earth. Shortwave radio users lost their signals. Satellites recorded strange noise. Scientists watched as the planet's upper atmosphere briefly changed its chemistry. That magnetar was tens of thousands of light years away. If an object so distant can reach us, it shows the sky is not always quiet. We also find hidden evidence in tree rings and ice. In the years 774 and 775, tree cores around the world show a sudden jump in carbon-14. That spike tells the story of intense radiation hitting the atmosphere. We do not have eyewitness accounts that explain what made it, but the trees kept the number layer by layer. Ice cores in Greenland and Antarctica hold small chemical traces that match sudden bursts of high-energy particles. These natural archives show that extreme space events have brushed Earth before, leaving fingerprints long after the witnesses were gone. All of those past events have something in common. They took the world by surprise because humans had built fragile infrastructure and little warning. Telegraphs, power grids, radio, satellites, these systems did very different things. But a single spike in space can touch them all. That pattern matters because it tells us two things. First, cosmic events can be local in effect, even when they are remote in origin. And second, we have grown more exposed as our technology has grown more complex. Think about how life has changed in the last few decades. Navigation relies on signals from a handful of satellites in precise orbits. Financial markets trade on timing measured in milliseconds. Commercial aircraft link into global networks to manage routes across oceans. A disturbance that nudges timing or produces bursts of electromagnetic interference can ripple through society in ways that are hard to predict. The Carrington event happened when telegraphs were new. If the same energy hit us now, the damage could be measured in lost infrastructure, grounded flights, blacked out cities, and a scramble of communication failures. That is why every historical comparison feels less like a curiosity and more like a warning. Then there are the near misses we almost forgot. Small storms that barely made the news. Satellites that lost attitude control for a few minutes. GPS errors in polar routes. None of those were catastrophic, but they remind us that Earth's magnetic shield is not an unbreakable wall. It is a dynamic system, and when the universe plays its notes in the right key, the planet responds. Which brings us back to Andromeda. If distant magnetars, solar storms, and ancient radiation spikes can affect the magnetosphere, the new event fits into a longer pattern of the sky reaching down to our world. The difference now is twofold. One, our instruments are far better. 70 years ago, we might have felt a small wobble and called it bad weather. Today, quantum sensors and satellite arrays pick up the tiniest whispers. Two, our dependence is far greater. A small wobble now can cascade into a real problem because so much depends on precise timing. Scientists also look at the pattern of past events to ask a deeper question. Are these bursts random or do they come in families? The record is mixed. Some events seem isolated. Others happen in clusters, years or decades apart. That uncertainty matters because a single event can be managed. A series of spikes, timed to resonate with Earth's natural frequencies, would be another order of trouble entirely. Let's step into a quiet laboratory for a moment, a place where the past and the future meet. Here, researchers line up graphs of historical storms, overlay them with modern measurements, and look for repetition. They compare tree ring spikes with satellite noise, and they search for patterns that might hint at cycles longer than human lifetime. Some say they see rhythms that match the motions of galaxies or the turbulent flows of cosmic plasma. Others see nothing but noise. The debate is healthy. It's also unsettling because the answer shapes how we respond. If the Andromeda event is just another echo in a long conversation, then the job is to listen more closely and harden our systems. If it is something new, a targeted pulse across a filament or a deliberate knock, then the stakes are different. In either case, history tells us to prepare. It teaches the same lesson the Carrington event handed down. Do not assume the sky is harmless. Because it usually island, the sky can surprise us, and the surprise can be costly. What gives historians and scientists hope is that we can learn. The past provides a blueprint. By studying old storms, magnetar flares, tree ring spikes, and power grid failures, engineers design better shielding and smarter fail-safes. Satellites can be put into safe modes when forecasts show a storm building. Grids can be rerouted, and critical systems can be given manual control. The old nights of sudden auroras and telephone sparks taught us painful lessons, but they also taught us how to respond. So as we fold the Andromeda spike into the tapestry of cosmic events, we do so with two attitudes: humility and action. Humility because the universe has surprised us before and will do so again. Action because the history we study gives us tools to protect our world. The magnetosphere is the planet's shield, but it is not invincible. The past shows that a single pulse can upset our world for hours, days, even longer. It also shows that careful preparation can keep one storm from breaking everything. Inside quiet offices and hidden control centers, the debate has already begun. Not in public, not in headlines, but in circles of power that know how fragile silence can be. The Andromeda spike has forced a question that feels both technical and philosophical. Do we respond? For some, the answer is simple. They argue Earth should remain silent, just as we have for most of human history. The logic is survival. If you don't know who knocked on the door, don't open it. A whisper across galaxies could expose our presence to something we cannot control. Silence, they say, is safety. But another group believes silence is riskier. They argue that a response is not optional because the spike itself was too precise to be random. If someone already knows where we are, then refusing to answer could be seen as weakness or worse, defiance. To them, a message back is a signal of intelligence, cooperation, and intent. The only way to shape the unknown is to speak into it. These conversations are not happening in open debate. They unfold behind encrypted walls in windowless rooms with digital clocks glowing red. Governments, intelligence agencies, and a handful of scientists sworn to secrecy gather at long tables. Some look exhausted, haunted by the weight of the choice. Others look hungry, as if the chance to make contact is too big to ignore. Plans already exist, drawn up years before, waiting in vaults under the name active SETI protocols. They describe how a signal could be shaped, amplified, and directed into space. Not a casual hello, but a carefully coded message, something that demonstrates intelligence without revealing too much. A puzzle, a sequence, a pattern that can be recognized without giving away Earth's exact technological ceiling. But hidden inside those plans is another layer. What if the reply must not be peaceful? What if deterrence is safer than dialogue? Engineers in military complexes study the mathematics of beacons and pulses, wondering if the same technology that carries a greeting could also carry a warning. It is not hard to imagine a coded flare that says, "We see you too. We are not defenseless." Outside these secret halls, the public remains unaware. News of magnetic anomalies trickles through science channels, but the full scope, the connection to Andromeda, has not been shared. The reason is fear of panic. If people knew that the sky had been touched by a message from another galaxy, how many would continue with their lives as normal? Would financial markets freeze? Would planes stay grounded? Would cities fall into fear? And yet, rumors leak. Amateur astronomers share strange readings online. Small forums speculate. A few videos appear, only to vanish days later, deleted or shadowed by algorithms. A pattern begins to form. Someone, somewhere, is controlling the narrative. In the middle of it all are the scientists who feel torn. Their loyalty is to truth, to discovery, to sharing knowledge with the world. But their access depends on silence. They publish watered-down reports, hiding what they know between careful lines. While late at night, their minds run circles around the question that haunts them. If the spike was a message, what happens if Earth stays quiet too long? What is most chilling is not the debate itself, but the possibility that the choice has already been made. Somewhere, in a hidden chamber, the button may have been pressed. The first reply already sent a coded signal racing back into the dark, carrying Earth's answer across the void. And the rest of humanity may not know until the reply comes back. The first sign that something had changed came not from a government announcement, but from silence. Radio operators across the globe began noticing a sudden, unexplained quiet across frequencies that had always been noisy with static. Entire bands of the spectrum seemed scrubbed clean, as if something powerful had swept a hand across the dial and erased the chatter. In Alaska, an amateur ham operator thought his equipment had failed. In rural Japan, a farmer who spent his nights listening to shortwave stations noticed the absence of the background hum. In Argentina, a group of students studying pulsars thought the sky had gone strangely empty. The truth was stranger. A global blackout of certain frequencies was being enforced. Satellites had quietly shifted their priorities. A hidden network of ground stations had activated, and behind it all, the first reply to Andromeda had already been launched. The signal was not a word, not a language, but a pattern. a pulse of mathematics, prime numbers strung together, sequences repeating in ways no natural object could produce. The kind of message that says, this was made, this was deliberate. It was beamed into the dark with precision, its target aligned with a filament of intergalactic space believed to stretch toward Andromeda. Those who authorized it argued it was harmless, just a handshake, just a way of saying, we're aware of you. But nothing in the cosmos is truly harmless. Even before the signal reached its destination, which would take millions of years at the speed of light, the consequences were already unfolding on Earth. Strange fluctuations appeared in systems that were supposed to be stable. Navigation satellites showed momentary drifts. Power grids experienced flickers no engineer could explain. Sensitive military radars picked up phantom echoes, shapes that appeared for a second and then vanished. To the public, it looked like coincidence. To the experts, it looked like response. And then came the storms. A series of geomagnetic disturbances rippled across Earth's magnetosphere, but unlike ordinary solar storms, they didn't follow solar activity. The sun was calm, no flares, no coronal mass ejections. Yet instruments showed the planet's magnetic field pulsing like a struck drum, vibrating with a rhythm that felt eerily familiar. It matched the cadence of the message Earth had sent out, almost as if someone or something had echoed it back. The scientists who first noticed were stunned into silence. Could a reply travel faster than light? Was it some strange resonance effect? Or had Earth triggered a system already waiting in place, a kind of cosmic switch, primed long ago, only needing a spark to activate? Governments doubled down on secrecy. Reports were classified, labs were locked, researchers were told to stop asking questions. Yet, in the quiet corners of the internet, whispers spread. People began noticing their compasses behaving strangely, their GPS units drifting. A sense of unease took hold, as though the world itself was tilting slightly off balance. And through it all, one question kept returning, heavy and unshakable. If Andromeda had been waiting, then what exactly had Earth just awakened? The last vibration came on a night when the skies were clear across half the planet. For the first time in history, people everywhere reported the same thing, a shimmering wave that rippled across the stars, almost like the night sky itself had become liquid. Some described it as a curtain of light, like the aurora but stretched far beyond the poles. Others said the constellations themselves shifted, bending as though space were a sheet of glass under invisible pressure. And then, stillness. Satellites stabilized. The magnetic field quieted. Instruments fell silent. It was as if whatever force had pressed against Earth had suddenly released its grip. But deep in the data, in the faint hum of the magnetometers and the long recordings of the quantum sensors, one final detail emerged. Hidden beneath the noise, beneath the chaos of the storm, was a pattern, a signature that matched not just the signal Earth had sent, but something older, an echo, an imprint buried in the magnetosphere, like a fingerprint on glass. It was precise, deliberate, unmistakable, and it carried the rhythm of a sequence known across cultures, across time. 1, 2, 3, 5, 8, 13. The Fibonacci sequence. The pattern of growth, of life, of order written into the fabric of the universe itself. Someone or something had answered. The implications are staggering. If the Andromeda signal wasn't random, if it wasn't noise, then Earth is not alone. We are part of a vast, connected web of intelligence, one that may stretch across galaxies, communicating not with words, but with the very forces that shape the stars. And if this was only the first handshake, what comes next? Was this an invitation, a warning, a test, or simply a reminder that we have always been watched? As the world turns back to routine, as governments bury their reports, and as scientists quietly argue behind closed doors, the truth hangs in the air like a shadow. We reached out, and the universe reached back. So the next time your compass twitches, the next time the night sky feels a little too quiet, remember this. Somewhere across the gulf of millions of light years, something has already set its eyes on us, and it may already be closer than we think. If this story kept you thinking tonight, don't stop here. Another mystery is waiting on your screen right now, and trust me, you don't want to miss it. Click through, subscribe, and join me for the next chapter in the unknown.